Well, hello and welcome to this little video lecture on bonding between atoms. You know, I was going to make another chemistry joke, but it turns out that all the good ones are gone. Argon, That's an element. It's a noble gas, in fact. Argon. There you go. You're welcome. Okay, what are we talking about today? Today, we are trying to learn how to be able to describe the difference between molecules and compounds, and also to be able to explain how both covalent and ionic bonds form. These are types of bonds, types of ways that atoms can join together. Okay, so first up, what's an atom? Here is something that you've seen before, right, which is just the definition of an atom. And an atom is the smallest unit of matter that has the characteristics of a specific element. So anything that can behave like a tiny bit of gold is an atom. And they cannot be broken down by ordinary chemical methods. So if we do a chemical reaction, we shuffle atoms around, we move the elements around, but we are not changing the atoms, we're not splitting them apart. And hopefully you remember that it takes nuclear methods, it takes splitting the atom to actually get, to break it down and get a different element. And that's not an ordinary chemical method. Okay, so what are molecules and compounds? You've probably heard these terms quite a bit, and we've already used them in class, but it's important that we distinguish them kind of carefully. So an atom, right by itself, can join together to form other things with other atoms. Sometimes atoms form with just other atoms of the same element, sometimes they're different atoms. So if you have two or more different atoms chemically joined, you have a compound. But if they are joined using covalent bonds specifically, you have what we call a molecule. So a compound is two or more different elements. Let's say salt is sodium and chlorine coming together. That's a compound. But a molecule is when any two or more atoms are joined by specifically covalent bonds. So Velociraptor notes that this says some molecules are compounds, but not all compounds are molecules, right? And so that can be a little confusing. Here's an example that I hope will make this a little more clear of things that are some are either molecules or compounds or both. So carbon dioxide, that stuff that we breathe out a lot, carbon dioxide is a molecule. How do we know that? Because the carbon and the oxygen are covalently bonded together. It's also a compound. How do we know that? There are two different elements involved, carbon and oxygen. Glucose, this is the simplest form of sugar out there. It is also both a molecule and a compound, right? It's a compound because there are three different elements, carbon, hydrogen, and oxygen. And it's a molecule because what's holding them all together are covalent bonds. Now we can take oxygen. So the kind of oxygen that we breathe in is O2 because one oxygen atom by itself is not stable. So it's almost never found alone. Oxygen is almost always found in pairs. That's why we call it O2. And O2 is a molecule because it is covalently bonded. So the two oxygen atoms are covalently bonded, but it's not a compound. Why? There's only one element involved. And then the opposite is salt. Salt is sodium and chlorine. And so that's a compound because there are two different elements involved, but it's not a molecule because there is no covalent bonding going on. And the same thing would go for a different kind of salt, calcium chloride. Calcium chloride, that's a calcium atom and two chlorine atoms to make a compound called calcium chloride. Okay, so why bonding? Before we talk about the difference between the two kinds of bonds, let's talk about why atoms end up bonding together. And the reason is this: atoms are most stable when their outermost energy levels are full. So electrons are found in energy levels, and the levels start closest to the nucleus and move outwards. So the first level can contain 2, and then the subsequent levels can contain 8. And that means that, generally speaking, for a lot of elements, we can figure out how many electrons they need to be stable by using either the duet rule. And the duet rule says that stable means having 2 electrons in the outermost energy level, like would be just this ring right here. And that's elements 1 through 5. So hydrogen, helium, and a few others, lithium, boron, lithium, beryllium, and I can't remember the fifth one. Anyway, those 5 elements want to just have 2 in their outermost shell. And then the ones after that want to get 8 because they will already have 2, and then they want to get 8 in the next one to be stable. And so in order to become stable, most atoms and most elements need to bond with other atoms. So here's an example of how this might work and what elements might be doing things. So lithium is element number 3. It has 2 electrons in its innermost energy level, which is good, but then its next energy level has 1. Its next energy level has 1, and it needs 8 for that to be full, for it to be stable. So lithium is really ready to get rid of that 1 so that it can obey the duet rule. Fluorine has 2 on the inner and then 7 on the outer. It's atomic number 9. So 7 on the outer, and that means it wants to have 1 more. It wants to have 1 more. So it's going to take from somewhere so that it can get that 8. And then neon is one of what we call the noble gases. They're noble as in, oh, we're noble so we don't mix with anybody else. So it's a noble gas, and it is already, by itself, the way it's found, totally full. Satisfies the octet rule. So neon, like all the noble gases, is very unlikely to react with anything. Okay, so how does the bonding actually work? How do atoms actually come together to satisfy the duet or octet rules? Well, there's 2 major kinds of bonds within atoms. One is called a covalent bond. Co, there's that word root that means sharing or together. Covalent. Valent actually refers to valence, which is a term for outermost electrons in an atom. So this is when the outermost electrons are held together. That's 2 nonmetals sharing electrons. So this is one of the ways that you can identify covalent bonds, is the atoms involved are not metals. The other kind of bond is an ionic bond. And in an ionic bond, one metal atom gives away an electron, and a nonmetal atom will take that electron. And in doing so, not only do they satisfy the octet or duet rules, but they get a charge. And so the metal, by giving away an electron, becomes positive, and the nonmetal, by taking an electron, becomes negative, and then negative and positive attracts, and that forms an ionic compound. And this is why we say a covalent bond yells at an ionic bond. Didn't anybody ever teach you to share? Right. Okay, moving along. So covalent bonds, again, just slightly more detail. Co means together. Valent means valence electrons, or the outermost energy shell. And covalent bonding occurs when 2 nonmetals share valence electrons in order to gain stable outer shells. So it's a sharing. That's why if you somebody offers you a joke about covalent bonds, you say, thanks for sharing. Here's an example of how this works in water molecules. So in water molecules, hydrogen and oxygen get covalently bonded together. And so I'm going to attempt to show you an animation of how that happens. If I can just get the correct thing to appear on the screen, here it is. So here you have a hydrogen atom. Oh, I got to reset this. Here you have a hydrogen atom and another hydrogen atom and an oxygen atom. Hydrogen is 1. It wants 2. Right? Both of these guys want 2. Oxygen is 2 in the inside. That's cool. But only 6 on the outside, so it wants 2 more. So it satisfies the octet rule. So here's what happens. The 2 guys share these 2 electrons, and so these 2 also share 2 electrons, and in doing so they get pulled really closely together so that these electrons are around the nuclei of both the hydrogen and the oxygen atoms. And so by pulling inwards and sharing, this creates a really strong bond. So covalent bonds are pretty darn strong. Okay, so and that's why water molecules end up looking kind of like Mickey Mouse. Okay, back here. Give it a moment to properly get back in there. All right, so that was covalent bonding, and when this comes back, we'll see an example of a covalently bonded molecule being propane. So propane is C3H8, which means it's 3 carbon molecules. See this diagram, 3 carbon molecules and 8 hydrogen molecules. I'm sorry, I'm saying that wrong. 3 carbon atoms and 8 hydrogen atoms, and these little lines in the diagram represent covalent bonds, and they're fairly tightly held. And that's why breaking those bonds by lighting the propane on fire releases lots of energy. So there's lots of energy being held in these bonds, and if you break them, you get lots of energy out. And that's what happens when you use propane, right? The stuff you would have in a grill. Okay, ionic bonds. Ionic bonds form when ions with opposite charges come together. Opposite charges come together. And they form when a metal gives away a valence electron and a nonmetal takes a valence electron. And in doing so, the metal becomes positive, it becomes a cation, the nonmetal becomes negative, it becomes an anion, and they get attracted to each other. So plus and minus attract, opposite charges attract. And that forms an ionic bond. And the name's Bond, ionic bond. Taken, not shared. It's a James Bond joke for you. Bonding is great, right? Okay, and here's an example of how this happens in a super common compound, which is sodium fluoride. So sodium fluoride is actually the compound found in your toothpaste that gives you fluoride. You may have heard your dentist say, oh, you need fluoride to protect your teeth. So this is how sodium fluoride forms. That's the actual compound that's in your toothpaste. So a sodium atom has one lonely electron in its outermost shell. I'll wait for the animation to reset. One lonely electron in its outermost shell. Fluorine has 7 in its outermost shell, so it really wants one more. So it's going to grab that one away from the sodium. Then the fluorine becomes complete, stable, right? But it also ends up with this negative charge because it has one more electron than proton. And sodium, by losing one electron, becomes positively charged. And then the two charges come together and they stick. They stick in an ionic bond. And so that's the compound that gets added to your toothpaste. And then when it goes into the water in your saliva, the sodium and the fluorine actually come back apart. And those fluorine ions floating around are the things that actually can help repair your teeth if you've been eating too much candy. Okay, so that's it for bonding. I hope you learned covalent bonding. That's all about sharing electrons. Ionic bonding, that's giving and taking and then coming together because of opposite charges. And I will see you in the next video.